Hi, welcome to the Predicting Mortgage Default presentation. The purpose of this presentation is to propose a refined model solution that will help the bank to accurately estimate the probability of default and make better lending decisions more efficiently. First of all, I would like to introduce you the Dream Team. Based on the Mango Solution Radar analysis, we have a great variety of skill sets. We have Akasha, Amy, and Jake, the communicators, Shiv, the technologist, and William, the modeler. Based on the strengths and interests, we allocated our roles and responsibilities accordingly. Akasha focused on insights and synthesis of quantitative and qualitative data. Amy focused on the identification of enhancement opportunities. Jake focused on strategy and creative writing. Shiv focused on presenting compelling insights for decision makers. And William worked on data analysis and building the model. Now, let's take a look at the background and understand what is the problem and why it is so important to solve the problem. On September 15, 2008, Lehman Brothers, one of the largest U.S. investment banks, filed for bankruptcy due to inadequate risk management caused by increasing mortgage defaults during the U.S. housing downturn. Since 2008, banks have increased their loan book size and are exposed to systematic risk related to housing market more than ever before. Predicting mortgage default rates of their loan book equips them to forecast and be prepared for any possible housing downturn. So how can we reduce the risk and improve the accuracy in predicting mortgage default? How can we create a maintainable risk model that we can use, but also provide that to the regulators? There are two key questions we need to answer before we start building the model. What are existing data sets that are relevant and can be used in building a strong model? What else can be added or aggregated to further improve the strengths of our predictive model? We explored the dataset and analyzed it using IBM Watson to build an elementary predictive model, which was then refined after review of academic literature, coupled with further analysis using R. First attempt was a single driver analysis in IBM Watson. The strongest single drivers are credit score, interest rate, and mortgage age. These factors all make sense. However, 79% of the data key points are key drivers of mortgage defaults in our current datasets, which means we will need to look at alternative models to cull variables from our predicted model. We then ran a double driver analysis to see if we can use double forces to further optimize the model. As a result, we found that credit scores lower than 714 and loan age about 20 months are likely to default with 78% of predictive strength. After the initial analysis and understanding of our dataset, the modeling process began. We started investigating new ways of increasing accuracy and precision within the model in R. The final model variables were selected based on business understanding and eliminating variables deemed irrelevant for mortgage default. Another feature engineering process was executed to create new variables to further avoid duplications in the model. As a result, the final model has a high degree of accuracy at 80% with 70% of sensitivity. The model was also tested against another model produced by IBM Watson, and it is proved to be a better model. Using this model, we predict that the risk of default will reduce if we select borrowers with lower interest rate at mortgage commencement, lower original loan to value ratio, lower debt to income ratio, lower unemployment rate at the time, lower age to original time of the loan, and higher credit score with 714 or higher. Last but not the least, we propose 3 ways to further extend the datasets. Capture complete set of data, introducing applicants' behavioral data, and adding unstructured data such as social media, driving behaviors, and volunteer history. Thank you so much for your time, and we highly recommend you to use this model to generate business values in reducing the risk of mortgage default.